Sean Wilson, and this is my final project presentation for GEOG482, Bike Share Hub Suitability Analysis. So, my project goal was to assess station placement for expanded bike share coverage in Eugene, Oregon. And to achieve this goal, I first did some research and I found a reference study. And this study was called Optimal Locations for Bike Share Stations, a New GIS-Based Spatial Approach. And in this study, GPS data on over 1.6 million bike share ride coordinates was used to determine new bike share locations in Baltimore City. And the study found that route usage had a negative correlation with proximity to certain amenities. And what this meant was the closer the stations and routes were to amenities, the higher the ridership. And the study determined a metric for calculating bike share hub suitability dubbed the Bike Station Suitability Score, and this score was calculated with regard to proximity to transit, attractions, restaurants, pubs, and existing bike stations. So my approach was to model my analysis on this study, and I decided to use existing bike share ride data to determine which amenities are the most popular among bike share riders in Eugene, locate areas with high population densities, and locate areas locate existing bike share hubs and LTD transit stops, and then combine all of these submodels together to create my own location allocation model. So the first step was determining popular amenities among existing bike share riders. So I first merged all bike share ride start stop data into one layer, and you can see the start and stop data pictured at the bottom right here. And then I used the facilities data layer to add a 400-meter buffer around each amenity, and I chose 400 meters because that's what the reference study used. That's what they determined was optimal. And then I used spatial join to find the total number of start-stop points within each amenity buffer, and this gave me a list of amenities, and then I sorted that list, and that gave me a descending list of all the most popular amenities based on start-stop data for bike share riders. So I chose the top 20 amenities with most ride start-stop points within its buffer as the popular amenities layer. And then here are the amenities that I chose, with the most popular at the top, the least popular at the bottom, and then I gave each of these amenities a score, with 40 being the most popular, and then 22 being the least popular, but still the most popular out of all the total amenities. So then I used data on existing bike share hubs and LTD transit locations, and I added a 300-meter buffer around each hub or stop, and you can see that layer here. We have blue is popular amenities, orange is existing hubs, red is LTD transit stops. And then for the next part of my analysis, I found residence demand, so I used the loads RAC data layer and I converted it to raster using polygon to raster, and each census block now got a value of residence in the block, and you could see the layer that was produced in this screenshot over here. So once I had all the layers, I converted them all to raster. So popular amenities, hubs, LTD stops, residential demand, all converted to raster, and then reclassified to fit a model weight table that I came up with, which is pictured here on the right. So for amenities, I used a Python function to assign each kind of amenity a score out of 40, which we saw previously. And this just meant in the raster layer, each amenity had a buffer around it, and the cells within that buffer got a value of whatever score that amenity got, and outside of the buffer, where there was no amenities, it was a score of 0. And then for existing hubs and transit stations, I gave it a score of 20 if the cell was within the buffer and 0 if not. And then for population density, I reclassified the data into a scale of 20. So census blocks that were the most populated got a score of 20. Census blocks that were least populated got a score of 0. So I got all my raster layers finished up. On the left is transit, LTD transit. Middle is the residence demand layer, reclassified in the 20-point scale. And then on the right we have the amenities, where each buffer is valued based on the popularity of that specific amenity. And then once I had all the raster layers, I used weighted sum to combine them together to create my final result, my final map. And this is what it looked like. So yeah, blue indicates areas most suitable for new bike share hub based on distance to popular amenities, existing bike share hubs, LTD transit stations, and areas of high population density. So we could see around downtown Eugene, there's a lot of suitable locations, and then up by Valley River Center, a little bit more East Eugene, South Eugene. Yeah, so this is my final product, my final result. And then here's my model builder diagram. Pretty much covers everything my analysis involved. And then here is a citation for the reference study that I used.